Look at this figure. Imagine that's a projectile. So this is the definition of projectile. You have initial velocity and you have an angle with respect to x-axis. Consequently, here you can have this motion here. V0, this is the angle here. And that's a projectile. So this angle can be anything. For example, 20 degrees, 25 degrees, 45, 80 degrees, whatever. And sometimes this angle is zero. If it is zero, you have something like this. Therefore, V0 is horizontal here. This angle is zero right now, this figure. Therefore, what happens to your trajectory? Imagine the ground is here. Imagine the ground is here. And this is your trajectory or path. Like this. It can happen. And that's projectile. But this is your trajectory, this green curve. Sometimes your angle can be negative. Okay, let's check it. This one is positive angle. This one is zero angle. And this one is negative angle. Look at this figure. You have initial velocity, but the angle is something like that. Therefore, you have negative angle. Imagine here, if you have this, If this is the ground at the bottom, this is the trajectory of the projectile. Look at this curve. Like this. V0. This is a trajectory. All of these three can happen. Sometimes you have positive angle. It depends on your condition. You can have this kind of projectile. Sometimes your angle is 0. This is the second figure. And the third one, it has negative angle. Okay, now, and you know, for all of them, you have acceleration. And that's gravity. Consequently, the acceleration of the projectile and acceleration of the falling object are the same. Both of them are gravity. Look at this figure, and that's very famous experiment. Imagine there is an object here. This is the first object. And there is a second object on the right side, like this. At the bottom, that's the ground. From the same height. You know, here, you have the same height for both objects here. H. Sorry. Let me change it a little bit. This one is better. From the same height, both of them are at the rest at first. I wanna, the first object, the left object, I wanna release it from this position. That consequently, it will fall. It will fall like this. The second one, I wanna shoot it to the right with the initial velocity of V0. It means here. So you have initial velocity, which is V0 to the right side. I want to repeat this procedure. I want to release the first object, the left object. I want to shoot the second object to the right side with V0. The first object doesn't have any initial velocities. But right object has initial velocity to the right. Of course, both of them will go downward. Both of them. But the first one is falling object and the second one is projectile. If I want to show you the trajectory, the first trajectory is here. This is the trajectory of the first object. The second one, you have a curve. You know that's a curve. Therefore, it's here. Sorry, it's not good. Like this. Okay, question. Which one has a lower time of falling? In other words, which one is faster to reach the ground? Object number 1 or object number 2? Okay. If you remember the definition of gravity, you can answer this. Sorry, you can answer this question. And this is the answer of this question. They're the same. I mean, both of them have the same time of falling. I'll tell you why. Because look at the first figure. First object here. Object number 1. And this is object number 2. Object number 1, you know, that's falling object and it has gravity. And you know initial velocity for falling object, that's 0. Therefore, you have height and you have initial 0 velocity at first, and you have gravity. Therefore, it will fall. The second object, you know, it will go downward, but it has curve. It is a curve. So along vertical motion, only vertical, forget about the horizontal motion. Along vertical motion, you agree that it has gravity because I discussed it before. Projectile has gravity along vertical axis. If you have this kind of gravity or if you have this kind of acceleration along the vertical axis, you should focus on the vertical velocity. Pay attention, V0 here, it is horizontal velocity. It is not vertical velocity. Therefore, here, you should focus on the initial vertical velocity for second object because gravity is vertical. So I'm asking, what is the vertical initial velocity for second object? Of course, it is not V0. V0, it is horizontal. Initial vertical velocity for second object, it is 0. It means it doesn't have any velocities along y-axis or vertical axis. Therefore, here, let's review it. Object number 2 doesn't have any initial velocity along y-axis. And it has gravity along y-axis, like object number 1. In addition, it has the same height like first object. It means everything is the same for both of them. Acceleration, initial velocity, and height. Therefore, if everything is the same, definitely the time of falling for both of them should be the same. In other words, they will reach the ground at the same time. Let me show you a figure in this regard from the textbook. Give me a second, please. Look at this figure. So the red object on the left side, that's falling object. And the yellow object is projectile. The first one, the first object is released from a specific height. The second object or projectile is launched to the right from the same height. Therefore, here they have the same height. Same height. And you know, Vertical initial velocity for first object, it is 0, it is released. Similarly, vertical initial velocity for projectile is 0, because V0 or initial velocity of this projectile is to the right, which is along x-axis, not y-axis. Therefore, this velocity for vertical axis should be 0. And you know both objects have the same gravity. It means everything is the same. Therefore, time of falling should be the same for both of them. That's very important, and that's very well-known experiments. Okay. Now, actually, projectile has many applications. For example, one of the applications is the basketball. Therefore, if you want to shoot the ball in the space, it's going to be a projectile. And you can discuss it like projectile motion analysis. The next one, imagine there's a helicopter, and the pilot of the helicopter wants to release a package. And this package should reach the specific location on an island. It means if the helicopter is going to the right, during the motion, if the pilot wants to release the package, he should release the package before reaching the island, because the package is a kind of projectile. Therefore, it needs a distance to reach the exact position on the island. Consequently, the pilot should release this package earlier to get the destination. It's very important. If, for example, the ball of the soccer, this is next example of a projectile. If the soccer player wants to shoot the ball in soccer game, that object or that ball is a kind of projectile, because it has the initial velocity and it has an angle with respect to horizontal direction. It's very important. Thank you.